All right, welcome everyone to the SDVoE booth Infocom 2023. I'm Laurent Masia from NETGEAR, proud member of the SDVoE Alliance. This session is called How to Master Multicast for AV over IP. Let's go. So why is that important? Well, it's important because in AV over IP, everything is multicast. Of course, you've got some exceptions in the lighting with SSCN. Some technologies use broadcast, but most of the AV over IP technologies can be 1G or 10G, and SDVoE use multicast. So that's the reason why you need to become proficient with multicast. So multicast is just one type of transport over Ethernet networks. You have unicast, 1-to-1. You know the MAC addresses and the IP addresses, class A, class B, class C, like this one, 1020. That's easy. That's what you get on your computers, even in your home networks. In the broadcast type of messaging, this is one-to-many. Of course, this would be criminal for AV over IP video distribution. And then you have the multicast. Multicast is a beauty. This is a one-to-many distribution. So see, you have one sender, and you can have only a few recipients that will get that stream because they are interested in it, but the others won't. So look at how multicast is working. First, you have multicast MAC addresses that always use the same first octets, 01005E. And then you have those multicast IP addresses that look very different from unicast. This is called the class D. It's ranging from 224.0.0.0.0 all the way up to 239.255.255.255. And no, there's no sticker on the AV endpoints showing the multicast MAC or the multicast IP address. This is all dynamically managed either by a controller or by some software configuration. So what is the multicast stream is always dynamic this way. So what does it take on a network to carry multicast? Well, you need to have an IGMP carrier. That's one function that you need on the network. And the second thing is the IGMP snooping. If you only have a network with an IGMP carrier, your multicast is turning into broadcast. So each single member of the VLAN domain will get that multicast. But if you have an IGMP carrier and IGMP snooping correctly configured on the switches, then you have a good distribution of your multicast. Only the interested receivers will get your video over IP. So let me take you through a quick example, and then we'll go to a real-world example. Okay, so in my example, I have a network, and I know that everything is configured right. So we have the IGMP carrier, we have the IGMP snooping configured, and I have 4 clients, PC A, B, C, and D. And so far, the network has multicast, but those clients, they don't need any. So they did not subscribe to any multicast, so nothing is happening, right? So when the IGMP carrier that is part of that switch as a feature, we have the IGMP carrier. When that IGMP carrier is sending a query saying, hey, what are you interested in? Well, PC A, B, and C currently say nothing. They send empty reports. They are not subscribing. But when they want to subscribe, those clients, PC A, B, C, and D, they are going to send a typical IGMP report. It's a IGMP join, in fact. So the PCA is going to send this unexpected report to the network saying, I want 239.11.100, and I want 239.11.200. I want 2 streams. And the others, they are going to individually subscribe to the 100, to the 200. The PCD will remain without subscription. When this happens, then on the switch network backend, you have a IGMP group snooping table that is automatically updated with those IGMP groups. So the port 1, where the PCA is connected, has now access to the 239.100 and 200 when B and C only access one stream, okay? Moving forward, when the IGMP querier will periodically, for instance every 600 seconds, send those IGMP queries just to make sure that those clients are still interested, then these devices will answer those queries by just saying, yes, keep going. I still need this IGMP. All right? So I know it's a little abstract. So because I'm on the SDVoE booth and a proud member of the Alliance, I prepared that for you. This is a real-world installation. You have a SDVoE installation with some encoders on the left. We call them T-axis. You have your RXs on the right-hand side, and you have your SDVoE controller connected to the network, right? So as you can see, you connected your transmitters, your encoders to a server, to an Apple TV, to a Sony Blu-ray, and to a LG Blu-ray. As soon as you plug a encoder to an HDMI source, then this encoder is bombarding the network with the IGMP stream. And you can see that, the SDVoE controller assigned those multicast IP addresses, 239.1.1.10 for the server, 239.1.1.20 for the Apple TV, 30 for the Sony Blu-ray, and 40 for the LG Blu-ray. So, as you can see, now all those encoders are sending the multicast to the networks, but because we have IGMP snooping and querier, nothing is getting out to the endpoints, right? The network is blocking all that. Now we have the controller. You can see that the receivers on the other side, they are connecting to a display, upper left, upper right, lower left, lower right. Those are their names. Let me take you to that example. To manipulate an SDVoE controller, you need to have a mouse on this example. And with the mouse, we are going to drag and drop the server, the transmitter 1, to the receiver 1, okay? So voluntarily, I put everything in pause here, right? So for now, I just did that. But what I want to show you is that at this very moment when you do that, you have the receiver number 1 sending an IGMP join to the network. So the IGMP general report from receiver 1 is saying, I want 239.1.1.10, because that's the multicast stream coming from the server. And immediately on the switch, you have the IGMP group snooping table doing the group with the port 16 where the R1 is, and the 239.1.1.10, you now see those white packets flowing to their destination. So this is how AV over IP is made possible, right? Because with SDVoE, you are controlling the endpoints, you are managing them, but when you want to make the multicast happen, the controller will instruct the receiver that will use these IGMP techniques to let the network know that they are subscribing to this or other stream. So now we can fast forward, because if you want to do the matrix, sending the Apple TV to the receiver 2, then the receiver 2 is going to send an uninspected report saying, I want 239.1.1.20. The switch is snooping on that. That's the IGMP snooping. The port 15 is put in that multicast group, 239.1.1.20. The packets start flowing. And from now on, the querier on that switch is periodically sending those queries, and R2 will confirm, yeah, keep going. I'm still interested into the 239.1.1.20. So let's go faster now, because you understood that the SDVoE controller is instructing the receivers, but the receivers, the decoders, are IGMP compliant, and this is why they let the network know, using IGMP, what needs to happen. So now we finished our matrix from this time the LG Blu-ray to the receiver number 4. All right, my next example is using a video wall this time. See, because those displays, they're already organized in kind of a 2x2. So that's why we call them upper left, upper right. So in the SDVoE controller, we just formed a virtual custom video wall that we call the wall 1, right? So what if I want to send the LG Blu-ray to that custom wall? Well, this time the controller is sending the same instructions, most likely, to all of your receivers. So each single R1, R2, R3, and R4, they are all sending an IGMP join IGMP group membership reports that is unexpected, just happened, saying we want to subscribe to 239.1140. So immediately the switch is putting a big IGMP group together with the ports 13, 14, 15, and 16, all for the 239.1140. And you see those blue packets, now they are flowing to each single receivers. So you tell me, how can they just display 25% of it? Well, that's not a network function. This is a SDVoE function, right? So they know exactly, because they got those instructions from the controller, which pixels or which parts of the IGMP stream they can take. But from a network standpoint, the network is forwarding the same IGMP streams to the 4 receivers. So now it's a real-world example. It's a deployment. You have switches, and if you want to see the IGMP group table, you can go to any switch and query that switch. Usually the command is show IGMP snooping group. That's the command on the NETGEAR switches, for instance. And here we can clearly see that in the VLAN 1, we have a whole lot of subscribers, so clients, receivers, decoders, right? With 1010XX subnet IP addresses. And they all subscribe to various IGMP groups so that they get that multicast. You will note that the 239.255.255.255, it's a session protocol for AES67. So those audio devices, they get subscribed to it for mainly AES67. But you see the other 239, 224, 223, 252, all those are multicast streams that those devices have subscribed on. And then you see the last column, this is the timeout. If you want to be a master in multicast, you need to learn how to read those IGMP group snooping table. The timeout column is extremely important because remember, the IGMP querier is going to stop sending the multicast after a period of time if there is no confirmation from the IGMP endpoint that the multicast is still desired, right? So the IGMP queries are sent in order to get this answer. And as soon as the IGMP query gets an answer, you get to the top of the exploration time, which is on that switch 600 seconds. So because all time outs seconds are in the above 500, it means that we have a very healthy system. So I now have for you a typical troubleshooting situation. Okay, so you are the multicast masters and you are a consultant on an installation. You have a whole lot of SDVoE endpoints and coders, decoders, everything works fine. But you have one decoder connecting to a projector that is super slow. When the customer wants to change the video from one source to another on that decoder, it takes a whole lot of time, like 30, 40, 50 seconds. So, because we already scrutinized the IGMP group snooping table, we can see that this decoder is fine. The IGMP group is there, this decoder is subscribing, but everything is very slow. So what do you do in that case? Well, you have no choice. You need to inspect the traffic between that decoder and the switch to see what's going on. So we have put a mirroring in place so that the traffic between the decoder and the switch gets sent to another port, and we have used Wireshark to look at the packets filtering only the IGMP packets. So in that scenario, 6 seconds in after the capture, 6 seconds in, we are asking the controller is asking the decoder to leave the previous video and join a new video. So the player was reading 234 32 77 43, and we want him to now play 234 32 77 112. 6 seconds in. What's wrong for you in that real world live capture? Well, first thing, you may notice that you have a lot of duplicates. It's like Messi, right? You see a lot of IGMP messages coming from the receiver. So that's not a good sign. Second, and I know I'm time conscious, so I'm going to give you the answer. Second, you see that at 6 seconds point 19, we see a leave message. So an IGMP report from the decoder leaving the previous video. So that's good. This is exactly when we action that on the controller. So that's why we have a black screen on the projector. But see, it takes from 6 seconds to 32 point something seconds time for that decoder to send the report, the membership new join report, to get the new video. So on that example, well, that's interesting because the switch is out of question. In fact, the switch is just waiting for the IGMP packets. And in this installation, the problem was solved by the NETGEAR Pro AV design team and the SDVoE manufacturer called ZV by just inspecting that decoder, and there was a firmware mismatch. So the decoder was running a very old firmware, and this was just impacting the IGMP delivery. Fixing up the firmware on the decoder, all that was gone, and we got an instant switching on the multicast. All right. I cannot do a session about multicast and IGMP without mentioning, well, the biggest problem with IGMP from day one, 25 to 30 years ago. With IGMP, you are flooding your multicast to the courier. That's how the standard works. So in this SDVoE installation, if you have a floor with a switch with 40 encoders and 40 receivers, everything is fine, everybody is working local. And if your client is saying, well, you know, I just want to have a few streams out of that floor to the rest of the network, you will probably be tempted, right, to only have a couple of 40 gig links, because you know nothing should travel much because you only have a few streams to move around. But if the courier is somewhere else in the network, then all those streams will be sent over, because the multicast traffic always must reach the multicast courier. So that's a huge problem, because here we are just blowing up the whole network. So there are some techniques in the network world to prevent that. It's called layer 3 PIM routing. With multicast PIM routing, the sports modes, the rendezvous points and all that, nobody is interested to start with multicast, so multicast stays local. But who wants to do multicast PIM to deploy AV over IP? Nobody, because it's too complex, okay? It's 60 pages of documentation just at NETGEAR. So the modest contribution from NETGEAR to the SDVoE Alliance and to the AV world in general is that we have re-engineered IGMP. We named it IGMP Plus. We don't flood. So in my previous example, you can have your SDVoE on the left switch, and you know that nothing will flood to the rest of the network. We called it IGMP Plus, all right? So with IGMP Plus, your SDVoE traffic always stays local until one subscriber somewhere else on the network subscribe to one of your streams. In order to make your life easier, we went further. With IGMP Plus, we now can do auto trunk. and auto lag so that you don't even really configure the uplinks, nor the ether channel or link aggregation so that you have a quite automatic network for your AV over IP installation. You want to focus on your AV, not much on your IT backend. All right? So NETGEAR is a different manufacturer. We partner with the entire SDVoE ecosystem. We have all those AV profiles that you can deploy. Any glitch, any design question before a project, any configuration issue during a project, every troubleshooting situations after a project, you're one email away. proavdesign@netgear.com. proavdesign@netgear.com. We have a team of IT/AV experts ready to support you. So that's why NETGEAR by now is by far the most recommended AV over IP switching platform. And well, that's my last slide, right? I wanted to show you a portfolio. The SDVoE usually, traditionally, has been deployed on the M4300 series at NETGEAR and the M4500. I'm extremely happy to release the M4350 new lines. We have a whole lot of great new switches on the NETGEAR booth 3723. Check them out. The green ones are shipping next month. We are standardizing on the 4350 with 10G, copper, PoE, and PoE Plus and PoE Plus, and we are standardizing on 25G uplinks for even greater capacity when you want to do your switch-to-switch interconnection. Thank you, have a great show, and see you